Okay. Okay, so I managed to order um, the two modules for the solid state switches. So I've just been putting some barrier cream on. Yeah. Still feel a bit itchy now and then because of this blepharitis. I think it's gone, but I keep feeling, is it coming back at me? It's like this invisible force that's lurking somewhere. But I was working out a block diagram. Can't see nothing now. So I've been working out a block diagram. Right. So the reason I do a block diagram is because it simplifies the actual basic construct of a circuit before you actually start to work out the individual connections. The block diagram makes got something in my throat now. Makes it a lot easier to determine the logistics. So the way it would work is I would have two separate solid state switches, which would be because it's reversed on my phone, so SSD1 and SSD2, and each SSD, each solid state array of switches would do two functions, and only one solid state switch array would be energized at any one time. If you had both of them energized at the same time, that would be very bad, because you would have battery short circuiting and fire and brimstone. You get the idea. So the way to control that would be to have a flip-flop circuit, and the flip-flop circuit would drive the SSD1. What it would do, SSD1 would basically configure one this battery array to be series, so it would configure the battery to be wired in series, and it would at the same time the other connections on the same solid state array would configure the other battery to be parallel, so it would switch the other batteries in parallel. So these batteries would be in parallel, these batteries would be wired in series by SSD1 array of switches, right? However, there must be some fail safes installed to prevent SSD2 from actually coming into effect unless SSD1 was deactive. So we would need to have we would need to feed the signals through a circuit, some kind of protection in between here and there, to make sure that this flip-flop, sorry, this is SSDs were disabled. And the way to do that would be to use some of the outputs, some of the extra outputs that come from SSD 1. We would use one of the outputs to basically ground or disable SSD2 from being able to flip the batteries, you know what I mean. So by doing that, obviously we would have full control of SSD1, the array, because there were multiple switches in here, by the way. There's probably, I think there's 8. I think it's an 8-bank one I've got on order. I've actually got them on order from China, so it'd be a while for them to show up. So we'd use one of the outputs to disable any possibility, would short out the input on SSD2. Now, when SSD1 was triggered open, so that all of the switches in here became open, which would basically disconnect all of the series and parallel batteries, right? So they would all be floating, right? At that moment, when was flipped over, then SSD2 would become active, and that would basically put that battery in parallel. I think that's right. Yeah, put that battery in parallel and these batteries in series. So it would switch them. Now, at the same time, you would use one of the extra channels on the SSD 2 to disable SSD 1, so that there would be no chance of a spike or pulse or interference of any kind from triggering that momentarily, because it would cause it fire and brimstone. Yeah, short circuit. We would have bad things would happen. So anyway, I'm going through the logic side of it. And once I get the logic side of it worked out and I understand it, then doing the connections is quite straightforward. So whenever you're working out a circuit, always start with the basics. You always start with the very basic, which is what block diagram is. You work out the logic, and then you work out the actual connections. Then, because it makes everything come a lot clearer in your mind. But normally, if you're trying to work this out, just going straight at the switches, you would get it's like a rat's nest. It's very confusing. So anyway, I thought I'd share that with you because I haven't obviously built that yet, but that's one of the ways of using energy conservation if we're running a free energy device or trying to create a free energy device. One of the first things you want to do is try to conserve energy and save and replenish or rejuvenate some of the batteries. And obviously one of the outputs you could use as a one coil or one output you could use as a self-regenerative to charge up some of the batteries. Now that's another issue that would have to be worked out later on. So by having some of them, the cells that are in series would be powering the device. We would have to have some kind of rectification, as in a bridge rectifier, so that the cells that are highest potential would be powering the device. And anyway, you get the idea. So I think you do anyway. So anyway, there would have to be some way of backfeeding energy, not backfeeding, that's the wrong word. There'd have to be some way of charging the circuit to make up for the loss, because there's always a loss, right? That's the most common problem with generating power, is the fact that there's always losses, whether it's thermal or resistive or whatever it is. There's a loss. But if you can replenish, if you can overcome that loss, then you could theoretically accomplish over unity. But that is the dream. That's what we're all looking for. And obviously, there's some people that claim they found it, but yeah, we've got to see the proof. But it's the search, it's the looking, it's the research, it's the interest that gets me more than anything. I just find it all fascinating. So anyway, thanks for watching. We'll see you later.